All right, this is the part 3 of using intercept form. So we're up to example 7, graphing a cubic function using zeros. So we've been graphing quadratic functions using zeros, but in one of the examples it told us that we could use the same concept to do that for a cubic function. So now we're going to look and see how to graph a cubic function using the zeros, the exact same thing that we were doing for a quadratic equation. All right, so you can see that this is an x cubed. That's what makes it cubic. The degree of 3 makes it a cubic function. And I can factor in x out of both terms here. So very quickly, I can rewrite this as y equals x times x squared minus 4. And then x squared minus 4, hopefully you have committed this to memory. This is a difference of squares. So we've got x plus 2 and x minus 2. So important to know those patterns and those formulas so that you can quickly get to the answer you need to, especially on a time test like the ACT or the EOC or something like that. All right, now that we have it in intercept or factored form, now we can use the zeros to solve. So we can say let x equal 0. Let x plus 2 equal 0, and let x minus 2 equal 0. So here's 1, and then I got to subtract 2. X equals negative 2. That's our second one. And knowing that it's a cubic function, I'm going to have 3 zeros. So I'm going to have x is 0, so I'm going to have a point here. X at negative 2, a point here, and x at 2. All right, so we used the zeros to graph those, but if you look at that, it doesn't help us with the shape of the graph because that looks like just a straight line, and we know it's not going to be a straight line because it's not linear, and only linear equations are equations of lines. So we can find points in between here to see the shape of the graph by letting x equal negative 1 and 1. So we're just going to say let x equal negative 1. Why did I choose negative 1? Because it's in between 0 and negative 2. And we already know where those points are. Those lie on the x-axis. So let's see where x at negative 1 is. So I'm going to take my function, y equals negative 1. I'm going to cube it, minus 4 times negative 1. All right, negative 1 cubed is negative 1. Negative 4 times negative 1 is plus 4. So that's going to be 3. So when x is negative 1, y is 3. So there's another point. I'm going to go up 1, 2, 3. All right, and then I can do the same thing here for x is 1. So let's say let x equal 1, y equals 1 cubed minus 4 times, it's supposed to be a 1. All right. All right, so we got 1 minus 4. 1 minus 4 is 3 again. So we know that we're going to have 1, 3 as another point on the graph. Oh, sorry, negative 4. 1 minus 4, that should be negative 3. All right, so 1, 1, 2, 3 is a point here. So you can see now I have 5 points, and a cubic function has 2 curves. So it's going to be and that's a poor graph of that, but another way to sketch that graph, to look at it a little bit nicer, you can type it in as x cubed minus 4x and hit graph. And this is what my sketch is supposed to look like. So it's supposed to go up, down, up again. So it's got that smooth curve. Mine is not smooth at all. So that's why I wanted to show you on the calculator. My hand is not as steady on the computer, but I'm trying. All right, we have one more example. I'm going to move this graph out of the way because I have a feeling I'm going to need more space to write than what I have left. So I'm going to put a line down through here. And we're going to get started on number 8. All right, so it says, example 8, the graph represents a cubic function. Again, that means degree of 3. Write a function in standard form. All right, now they give us the x-intercepts, which means they're giving us the zeros. So we can take the zeros, turn them into factors, so we can put it in intercept form to start off with. So to write this in intercept form, remember we've got y equals a times x minus p, x minus q. And since we have cubic, we're going to do one more factor, so x minus r. And the only reason I did that was because PQR. Just following in the pattern there. All right? So y equals a. First thing I'm going to do is plug in my p, q, and r. So x minus 0 would be the first one. Okay, you can see this right here, 0, 0. And then x minus q. So x minus q would be x minus 2 would be the next one. And then x minus r, you can see over here would be 5 because that's 5 zeros. So x minus 5. And remember, x minus 5 set equal to 0. Add 5 to both sides. That's where the positive 5. So the factors do have the opposite sign as the zeros or the x-intercepts. All right, now we are given one more point, 3, 12. So we can take 3 to 12 and use that as our x and y value. So 12 would be our y value. Now we're going to be left with one variable. X is 3. All right, so I'm using this up here as x and y. So 3 minus 0, 3 minus 2, 3 minus 5. All right, that leaves only a, which means we can solve for a. So let's first simplify what we've got. 3 minus 0 is just 3. 3 minus 2 is 1. 3 minus 5 is negative 2. So 3 times 1 is 3. 3 times negative 2 is negative 6. 12 equals a times negative 6. Divide both sides by negative 6. And now we have a equals negative 2. All right, once we have a equals negative 2, we can plug that back into our intercept form. Y equals negative 2, x minus 0, x minus 2, and x minus 5. Now it says the graph represents a cubic function. Write the function in standard form. So once again, we got to put this in standard form, which means we have to multiply it all out. All right, running out of room here, but I'm going to try. All right, so I've got negative 2. X minus 0 is the same as x, so it's just going to be negative 2x. And then I'm going to multiply these two binomials together. So x times x is x squared. Minus 5x and minus 2x is minus 7x in the middle. And then negative 2 times negative 5 is plus 10. All right. So I'm going to have negative 2x times x squared. Remember, properties of exponents. Same base, add exponents. So it's going to be negative 2x cubed. So that's our cubic function. Negative 2x times negative 7x is plus 14x squared. And negative 2x times 10 is negative 20x. All right, so that's a little bit crowded in there, but Let me see if I can write that last part there a little bit better. So you can read it. So it'd be negative 2x cubed plus 14x squared minus 20x. All right, and that is our cubic function in standard form. How do I know it's in standard form? Standard form means it goes in your highest degree down in descending order. So I've got x cubed, x squared, x. So I know this is now in standard form.